Hey, what's up, everybody? I'm here with my good friend Aaron Leese, who's out in the in Chi-Town in Chicago. How you doing, Aaron?
Doing well. How you doing, Josh?
I'm doing fantastic. Finally enjoying some nicer weather out here in England. So yeah, England's an unpleasant place to be in the winters. So
Hey, tell me about it. We got a snowstorm like 2 weeks ago.
oh man, yeah, they don't call it the Windy City for nothing.
Yeah.
So Aaron and I have been talking. So this is something that I've been seeing a lot in the Discord chat as well, and I've been talking a lot with Aaron. And we've been meaning to do this video for a while. We wanted to talk about visualization. So how do we get data that we're streaming into our audio app, and how do we actually visualize it on the screen? And talking just about, in this video, we're going to talk about basic concepts around that. How do we actually get the data over to where we can actually put it on the screen? Where is it supposed to be put on the screen? What are we not supposed to do in terms of mixing our data with our visualization? And what are some basic rules around that? And so Aaron knows a lot about visualization and creating UIs. And so he's been nice enough to lend us his expertise for this and subsequent videos that we're going to do. So this is going to be a 3 or 4 part series. So thank you, Aaron, for taking the time to come on onto the channel and lend us your knowledge and experience.
Yeah, anytime, man. We've been talking about this for like what, 5 months. We've been talking about doing this video.
I think
we'll see if we got, every time we talk about it, the video gets a little bit longer. We'll see how much we see if we can get through it all today.
Yeah, great. So we thought that this first video should be just the very basic. What are some basic concepts around painting something to the screen and getting data onto the screen? So where shall we start, Aaron?
Yeah, well, no, I like your framing there of it, like a concept. And we're talking mostly vector-based programming here. So there's 2 ways to look at this, right? A lot of people, you can get images and like put those on the screen, and that's one thing. But even if you're doing that, even if you've got a plugin that's got a meticulously kind of photoshopped, really good looking background and everything else with it, at some point you're going to need what we call vector-based programming, right? Like at some point you're going to need, there's got to be a waveform, or there's got to be a FFT output, or there's got to be like some kind of indicator that's going to move with the audio that's probably not going to be based on predetermined images that you've like photoshopped up. So that's the type of code that we're looking at today. That's the type of code we were talking about. So just by way of example, let me open up the kind of final, what the overdrive. So this is a plugin I developed. And when I do it, everything is vector-based, right? So you can see these are like very simple sliders in that it's just a box with, part of it painted in, that kind of thing. So how do we, if you wanted to do that, if you wanted to say, I have this or that little, like one little widget that needs to be drawn with code. I don't have a Photoshop file. What I have is an idea that I want to draw the text and draw a line and, whatever else. How do we do that? So by way of just like looking at basic thing and thinking about it for a second, and then we can kind of go from there into like talk about the canvases that we're drawing on and stuff. I assume you don't hear this, but I do.
I hear it.
Oh, you do?
Yeah.
Well, let me turn it down. Then the idea is like all of these things are being drawn just with like lines and everything else, right? And you want them to be responsive so that things jump into the frame when they should. This is the one that I want to focus on because this is the waveform. Mm-hmm. So the waveform of the audio coming in, what do we do to display that?
Mm-hmm.
Yeah, and I should figure out a way that this, here, let me just, you riff for a minute and I'll turn it off over here.
Yeah, so this is really good. As you said before, this is about how do we get data. So you're going to have audio that's going to be coming in to your plugin in real time, and ways that we can visualize that. And as you can see, Aaron's done a really nice visualization that involves. You can see that there's color that's based on frequency, and even just the more simple UI elements that you have, where you have an indicator that fills up a rectangle with a certain color based on what the value of it is. So there's a lot of really nice stuff in here that we could talk about that I'm sure our listeners will be interested in.
Yeah. So, I mean, you wanted to kind of ease into this. So maybe we talk this video, we take a look at, how do we get the data and just draw like the very simple kind of the first step for this waveform. And then we'll get into like, well, how can we improve it? Like, what are the, how do we make it fade? How do we make it move? How do we resize it? How do we do all these other things to really make it look good?
Mm-hmm. Yeah, great. That sounds good.
Cool.
Where shall we start?
You're leading this thing, man.
Cool. So okay. So let's just start. Let's just start with the data. So we have audio data that's obviously coming into the plugin. This is an Overdrive plugin, and we can see that the first step would be, okay, so how do we take the audio, which is going to be a bunch of floating based numbers, and how do we actually get that into a place where we can actually start looking at visualizing that? So what would the first step of that be?
So step one would be, I guess, to think that think of two things, right? One is the UI and one is the audio processor. So we have this audio processor, it's got audio going through it, and we've got this other thing in Juce, it's a component. I've subclassed it, so it's color shifting component for me. But a component, which is a UI box, basically. Mm-hmm. So a component is like some object on the UI. So before we even like figure out drawing stuff, let's talk about what the audio processor needs to do. It's got audio streaming through it. What does it do to like capture that audio and take those numbers and put it in a form that the component can then use?
Yeah. So you made a great point, and this is one of the biggest mistakes that I see in my discussion in the discussion groups and you brought up two parts, which are the audio processor and the editor. So basically what Aaron is saying is that those two parts should not be mixed up with each other. So you shouldn't have audio processing that's happening in your editor. So the editor think what does the customer see? Yeah. What is the person seeing? They're seeing the UI, they're seeing the graphics. The audio processor is what's happening in the background. That's the raw data, the raw math of what's actually happening in terms of numbers for your plugin. And those two parts should not mix. So you should not have any sort of visualization stuff happening in your audio processor, and you should not have any audio processing, number crunching, raw number crunching that's DSP that's happening in your editor. Okay. So great. So maybe we should start in the processor, actually, where we actually
totally
have the numbers coming in.
So let me jump us there, right? So the thing we're looking at now, amp oscope, OSC scope, is an oscilloscope. That thing is a fancy name for the thing with the waveform. And then all components have these paint routines, right? But just to jump ahead, here's where we're getting the data. Mm-hmm. Here's this history array of floats, whatever. But what is this? Like, let's dive in and figure out what is actually happening. Get history is returning just this history array. We'll talk about all this in a minute. But now you can see I'm in my Overdrive plugin. Overdrive.h is probably, something here that is doing the processing. Overdrive processor. This is an internal plugin. Again, I'm subclassing stuff, but it's an audio plugin instance, right? Which is in Juce is a type of audio processor, which is an audio plugin. So here is my plugin, in this case, internal plugin, and it's got 4 oscope. So for my oscilloscope, I need some data that I'm going to hand over, right? So I create a float array, and I create something that tells me how long the array is going to be. Now, more advanced coders are probably already like looking at me a little funny because there's better ways to do this. There's other ways to do this. Part of what we're doing today is going through and like, we're going to remake this a little bit better. But for the kind of amateur programmer, if you're just starting out, this might be a good starting place where you've got your plugin and you say, okay, at the end of the day, I think I'm going to be handing over an array of floats to my UI.
Mm-hmm.
So we've created that array of floats. We've created, and in this case, I have something that just states like how long that array of floats, how long it should be, how many samples should be in it.
Mm-hmm. Yeah. So just to kind of build on what Aaron was saying. So right now, Aaron is in the processor side of his plugin, and just to kind of simplify it down, and that you have an array that you've created, and it's an array of floats, and this is a history. So you're going to have the incoming audio, which is going to be floats, and that you're going to capture these floats with your history. Now the history is going to have a certain type of length. So you don't want it, because what's going to happen is if your array doesn't, if it just keeps building and building, well, that's going to hog up. Then it's just going to hog up all the memory on your computer. So you want to just have a length of that, so that after, you don't need 50,000 values of your audio. You probably need like maybe 500 or 1,000.
Yeah, it looks like in this case 400, right? So at some point we were kind of hacking this together, and we go, okay, well, we need a length. Length is going to be 400. If you think about on the UI, how big is our the place where we're drawing the waveform, right? Well, maybe it's 400 pixels wide. Yeah. Maybe it's 800 pixels wide. Maybe it's 5 pixels wide. But the point is, if it's small, if it's only going to be a couple hundred pixels, you don't need 10,000 points in an array to draw something that's going to be small.
Yeah.
Right. In this particular one, it can be resized, and because Juce, we'll kind of get there later, but since Juce has like paths, we're going to create this like path, which if you scale it up, Juce is real smart about doing anti-aliasing. It can like draw it, even if it's 400 points on a big canvas, you can draw it and make it look good. But generally you want, a few hundred points if it's a few hundred pixels wide. You want to keep it like in the ballpark.
Yeah, exactly. So great. So we made an array. It's called history length. We know that the length is 400, and now we have a place where we're actually adding. So you're putting zeros. First of all.
Yeah. So this is when again, this is one way to do it. There's better things. We're gonna like go over all of this again, but when the audio processor starts up, I've got this array that I know I'm going to want to have about 400 points. So the first thing I do is I just add 400 zeros.
Yeah.
Right. So I'm gonna zero it out. Now we have a blank array of 400 zeros, which presumably the UI will do something with.
Yeah, and just for beginners, the reason that he's doing zeros there is because if he doesn't do that, it's going to be random values. So you're going to have, I believe it's going to be random values. So make sure that you zero it out or that you clear it out before.
Actually, if it wouldn't be random values because it wouldn't have cleared the memory yet. So it would just be a non-existent. We could ensure allocation. So there's another function on there. Here, we'll just do it real quick. There's another function on there called ensure allocation, or ensure storage allocated number of elements. So if I did this, right, this tells it, hey, my array needs a block of memory at least 400 long. So that doing this, it would get to that point and it would like block out 400 spaces for floats essentially. Yeah. And now it's full of junk.
Yeah.
Right. So the better way to do it is to just, in this case, adding them one at a time. It's not particularly fast, but it doesn't need to be here. And, we should remember that there's always a possibility with this sort of thing, when you're adding a bunch, that you overflow where the object is supposed to live. And then the computer says, oh, this object got too big, and it moves it, right?
Yeah.
So just bear that in mind, because, for example, we want to be careful about reallocating arrays inside the audio thread, like in the process block, because that's got to be super, super fast.
Yeah.
We don't want to like block it up. So that's one of the reasons why, again, we're going to kind of improve on this process as we go today. But first draft, nice hacky little thing. We've got 400 arrays, all 0, 400 points in an array, all 0, and we're ready to go.
Yeah. Another nice thing about using an array instead of a vector in this instance is that it makes sure that because a vector is dynamically, you can dynamically increase the size of a vector. With an array, that's determined at compile time. So that once you have those 400 places, it's 400 places for the lifetime of the app. You can't.
That's not actually totally correct.
Oh, is it not?
So this is a difference between Juce Array and Stead Array.
Oh, I thought it was Stood Array. I thought it was a Stood Array.
So this is a Juce Array, which is a different kind of thing. I that's a little confusing for anybody. But if we had done this kind of thing, right? Stead Array history, which you can totally do. That's a valid starting point too. And for people that are seeing this who are comfortable with the idea of using a Stead Array, you could do exactly what we're doing with a Stead Array. You could even do it with like there's a number of types of like memory blocks that you could do this with.
Okay. Yeah. So that was a bit of confusion on my part. So yeah, so you have two different types of arrays in Juice. So you have a stood array, which is the array from the from the standard template library. And that has to be determined. The length of that has to be determined at compile time. So once your app is built, you can't actually do like any sort of pushback or emplace back or anything like that,
right?
Because the size of it has to be determined at compile time, as opposed to a Juice Array. When you see a Juice Array, when you think Juice Array, think basically like a vector. So so it's essentially a vector, more or less. So
Juice Array's got all these fun, like there's how big is it? What's the size? Is it empty? But we can always add to it.
Yeah. Yeah.
You can even add sorted. They can have sort methods. Like arrays are, Juice Arrays are great little creatures. There's ways in which you got to be careful, because the thing we were just talking about, because they can grow and shrink, they sometimes need to be reallocated, which you never ever want to do in the audio thread.
Yeah. Is there a design reason that you've used Juice Array over stood vector? Or was it just
no? And this is why I've said a couple times, this is like a hacky quick version of it.
Yeah.
I wrote this a couple years ago, and at the time that was my comfort. That was like my sweet spot.
Yeah.
So I thought it might need to be the fact that we're not resizing this argues very much for that approach, right? For saying like, we don't need a vector, we don't need a Juice Array. This is overkill. And not only that, it could get us into trouble. So wouldn't it be better to have a solid memory block, a Stead Array or something like it that wouldn't change?
Yeah, great. So just to kind of hit the final point home. So we're dealing with a Juice Array, and as Aaron was saying, you're in a position where when you're first creating this object, you're allocating 400. You're allocating 400 spaces for your array, for your Juice Array, and that what may happen is if you got into a position where in your audio thread, when I say your audio thread, where it says get next block, or where you're doing your audio callback, where you don't want to get into a situation where somehow you're resizing those 400 spaces to 500 spaces or 600 spaces or whatever, because what may happen is that because sometimes memory, like objects in memory, may be next to each other, when it tries to allocate that 400 to 500, it may say, oh, I don't have the space for that. I need to take this whole array and I need to move it to another place in memory. And then that's where you get into what Aaron was talking about, which is called blocking, where basically what's going to happen is when it's doing that allocation, you don't know how much time that's going to take to allocate. Yep. And that's where your audio could stutter, or where it could stop for a moment. And because
it just takes a lot of CPU, right? So it might take up too much time to do that, and then your audio block, like you said, ends up stuttering because it falls out.
Yeah. So rule of thumb along with that is anything that you do anything that you do within the audio thread, there's kind of this rule of thumb. Make sure that you know how much time it's going to take, or that every time that you do it, that it's going to be the same amount of time. You don't want to have something, because like a memory allocation, you're not sure how much time that's going to take. And those are the type of things that can interfere with your audio.
Yep. And if we jumping ahead here, now we're in the process block, right? So people are probably familiar with this, but remember, we're thinking about two things here. There's a audio processor and there's a UI. Inside the audio processor, there's a thing called process block. Process block is the thing which is run every time there's a new block of audio. So when you're changing the settings and you have like 44.1 kilohertz is the speed and the audio block size is like 512, that's the thing where thousands of times a second this function is run and 512 new samples come in. So that's where we're at now. So now we're going to talk about, okay, what are we doing with those samples to get them into the history? And just before we kind of get into those details, similar thing here, like this is not necessarily great code, because we're using a couple array methods. We're adding to the end of the array, and then we're removing from the beginning of the array. Now, is that smart enough that it's never going to move the whole block? In this case, it happens to be, because it's going to, the storage allocated is a little bit larger than it needs to be, and we're going to add a few and then remove a few. And I think it shifts it all over, but I could be wrong. If it's not shifting it over, then this thing is moving through memory, which means every once in a while, whole thing's got to be lifted up and moved to a different location. So not the best way to do stuff. I think if I remember right, one of the Juice demos does it basically in the same way, because even though it's not the best way to do things, even though like it violates some of the golden rules of audio programming that we're just talking about, it's not really going to blow up all that often. And on the UI side of things, there are things you can do to mitigate, which we'll see in a second. So, not a great way to do it. There's better ways to do it. But if you're just like hacking something together to see that it works, and this is what you're comfortable with, go for it.
Yeah.
Okay.
Great.
So, shall we talk about the data?
Yeah, let's talk about the data. So,
cool.
so you're talking about going through this, right?
Yeah, and so just to preface it, right, because I know people are looking at this and they're like, wet buffer? What's a wet buffer? Is that a Juice thing? Whatever. This is already, so this is partway through. So this is where your DSP code lives, right, in a process block. In my case, it's like subclass a little bit, so it's process block internal. But here's our audio data. This buffer is what's coming in, and then this process block gets run, and then what's in that buffer is what's going out. Right? So same buffer being used coming in, play with the data, and then it's going out. And this is the MIDI messages that are coming in, and also the MIDI messages that are going out. Now, we don't need to talk about what all these things do, but we have a few different buffers. We're doing some magic. We're adding some pre-gain, copy it to the mix buffer, copy it to wet. We run this, whatever the fattener is, soft clipping algorithm, some, whatever else this thing is doing. In this case, it's an overdrive, so it's doing a bunch of overdrivey things. Once we get done with that, we've done our limiting, we've done our post gain, so we're at the very end of this signal chain. And now we say, well, that's what I want to display, right? I've got my effect has done things to the audio, and now whatever that last step is, that's what I want to display. In my case, I want to display the wet buffer, right? So whatever the effect has done to the initial audio that came in. So this wet buffer is an audio sample buffer. This is kind of a deprecated class. Usually you see them written like this now. Audio buffer. Audio buffer flow. Yeah. So this is like old school, the way they used to be. So like that. But we're going to go through that. So in our case, we have maybe 512 samples that's been cycled through. We've done some stuff to those 512 samples. Now we want to take them and pass them to the UI so that they can be drawn. When you think about audio signals, and we're not going to get too much into like what anti-aliasing is, but if you don't understand it, like it's a thing to look up and figure out. Audio signals are very fast. There's a lot going on, right? We have 48,000 samples a second, or 44.1, or maybe 92K or whatever. We have a lot of samples coming through. We don't actually want to draw every single sample, right? That's faster than we mere mortals need. So the first thing you might do if you're doing this, and you're kind of new at it, is you might just say, oh, I'm just going to grab that audio buffer, I'm going to put it in my float array, and then I'm going to draw that on the UI, right? The UI is not updating anywhere near fast enough for that. So maybe you only get every like 7th or 8th or 10th frame of 512 or block of 512. So now you're getting like every, a flash of what the waveform looks like, but you're missing a whole lot of it. So that's no good.
Yeah.
So you say, okay, so I don't need to display every sample. So I'll just display some of them. So maybe I just take every 5th sample or 100th sample or whatever and write that to the array. Maybe you do that, and then you see that your array is mostly empty. So because you only got 4 samples or 5 samples. Oh, okay. So what I really need to do is I need to take 4 or 5 samples, put it in the array, remember where it is, and then next time we do this, put another 4 or 5 samples in, right? Mm-hmm. So I hope that all made sense. Again, if it didn't, you want to kind of read up on anti-aliasing, think about, we don't represent every sample. We want to sample the waveform. So we want to take just every here and there. Yeah. If we're really getting technical about it, you usually want some kind of smoothing algorithm because, so this is just for display. This is not for like scientific purposes. If this was for like really rigorous scientific stuff, we would also have to think about the fact that if you're getting every 10th sample, there might be a sample, like maybe sample number 0 is at a value of 0, and sample number 10 is also at a value of 0. And if you look at that and all you've got is sample 0 and sample 10, you'd think it was all zeros, right? So you could miss the fact that like, oh yeah, sample 5 is, a million or whatever. So there's all these kind of creative ways we can think about. You might want to cycle through the whole buffer and find the maximums, right? And so you make sure that you draw the maximums, stuff like that. So that's another way to do this. Taking a look at this algorithm, this is a very simple one. All this does, let's take a look. Okay, so for sample number, all the samples, we're going to go through every single sample and then just add the sample every 20 or so to the history. Oh, every 10 or so. I must have changed it at some point. So this is modulus, right? Remainder. So we say, oh, we're at sample 11. What's 11 remainder modulus 10 is 1. So we don't do anything. Go to the next one, right? So only if it's sample number 0, 10, 20, 30, 40, etc., are we going to use the sample at all? If you think about it, this is not, scientifically correct either, because you're going to end up with like 2 extra samples at the end. Well, if it's 512, right? You get 0, 10, 20, blah, 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 all the way up to 510. And then there's 2 samples. So you're not even accurately sampling every 10, because when the next buffer comes in, you forget about the fact that you had 2 samples and you reset to 0, right? Yeah. So like in this weird, tricky way, again, that's like signal theory and sampling, and we could get more into that if we needed this to be a more scientific, super realistic representation of the wave. We would want to counter so that it goes 5, 10, and then it goes 1, 2, and then when it gets the next buffer, it's starting on, this is sample number 3 in my little buffer. Yeah. So I hope that's all clear. We kind of jumped over a bunch there. But again, in our sort of hand-wavy, simple way of doing this, all we're doing is every sample that ends in a 0, 10, 20, 30, 40, we go through and we say, okay, what's the wet buffer, which is where the effect is in this case? What's the left? What's the right? Looks like it averages. Yeah, each one divided by 2, add them together. In our case, we're not even doing absolute zeros, so it's possible that you would get, if left and right were mirror images of each other, they would cancel each other out, and we'd get a flat line, even though there's audio coming through, right? Another way that this is not a perfect algorithm, another improvement we could make. But, it's going to end up pretty good. What it's going to do is it's going to look at the incoming audio. It's going to take left and right every 10 or so samples, and it's going to throw that into the array. In this case, we have this history array. We already know it has 400 samples in it. This is just adding them. So it's adding them to the end. And then it does a quick check each time, and it says, how long is this array? And if it's now longer than 400, it removes a couple from the beginning, right? So as long as it's longer than 400, drop a few from the beginning. Again, here's our disclaimer, like this is not the best way to do it. It could end up resizing or whatever else, but this is a great, simple, easy way to do it. And for the people that are comfortable with, for example, stat array, you can think of ways that would use stat array that would be exactly like this, but would be a little bit smarter, because instead of adding it to the end, it would just keep track of, have a right marker, right position. And if the right position gets to 400, you go back to 0, right? And as long as you know where the right position is, you can read in the new ones starting from that position. So is that all clear? I'm kind of off on my own here. Make sure we're on the same page.
Yeah, so I think there were a lot of great things in there, and I'll just maybe simplify them down for our beginners. So first thing is that if you think of an audio stream, so you're going to have an audio stream that's coming in at 44,100 values or 48,000 values a second. So you're going to have the problem with the UI is that the UI isn't running at the same rate as what your audio callback is. Your audio callback is a high priority thread that's running very quickly, and it has to run very quickly and very efficiently in order to ensure that the audio that your audio data is getting into the speakers at the correct time. So your actual painting to the screen, your actual drawing is refreshing as well, but it's not going to be refreshing nearly as fast as your audio callback. So then you get into a situation where let's say that you're looking at 1 second of audio data, then you would have 44,100 values, in that second if we were working at that sample rate. And so we're saying, okay, well, we're not going to be able to accurately display the 44,100 values all onto that block of that UI block. So what we need to do is we need to pick and choose which values that we're going to actually pick out so that we can give the viewer an idea or the basic kind of generalization of what's actually happening with the audio. So in this case, Aaron is using a modulus function. So if I'm not going to go through Modulo, but Modulo is like an amazing thing for programming. So if you don't know about it, go research it. But this ensures that essentially Aaron is taking every 10th sample and he's taking it and he's putting it into his history, and then in the following line 341, he's ensuring that the size of the history never goes above 400. So what happens is that if you're adding another value on the end of your array, well, you're temporarily going to have 401 values. So he's saying, okay, so if it gets over 401 values, what I want to do is I want to remove the value at the very beginning. And as Aaron was saying, there are a number of different issues that you can run into in this situation. So first of all, if your buffer size is 512 values, then you run into a situation where if you're taking every 10th value, what happens is that you're going 0, 10, 20, 30, 40, so on and so forth, all the way up to 500, 510. So then you're at 510, and then if your buffer size is 512, you're going to have 2 samples that you haven't accounted for. And then when you get to the very end of that audio callback, when you go the next time around, it's going to start at 0 and it's going to forget that you had 2 values at the end. So he's saying that there may be ways that you want, if you were doing something, then you wanted to make sure that it was very accurate, that you want to account for those extra 2 values at the end. And the other thing that we were talking about was that an alternative to this type of approach, where you're temporarily adding a value to the end of your array and then subtracting a value from the beginning. So an alternative approach may be something more like a circular buffer, where when you get to the end of when you get to the end of the array, rather than if you go over the length of the array, rather than allocating something at the end, what that would do is that would actually go back to the beginning and then put the next value into the very beginning of the array. So at the very beginning of it, and if you have questions about how to do that, check out the tutorial on circular buffers that I did a few months ago. Great.
Oh, cool! I haven't seen that. We should.
Yeah.
That'll come into play too if we get to the. One of the ways we're talking about rewriting this thing is basically with circular buffers, but with lock-free queues, which are this kind of like advanced special version of circular buffers. Okay, check this out. You want to see a little experiment?
Yeah, let's do it.
So a second ago, we were doing modulo every 10 samples, right? Now we're doing every 100 samples, and you'll notice, right, very different. Before, this looked like it was just in place, like reacting. Whenever it got loud, it would do this. I could turn on the audio, but I'm not going to bother. Now it's kind of scrolling, right? It's actually doing exactly the same thing, but last time it was scrolling so quickly you didn't notice. So this is where we were talking about, if we didn't have modulo at all and we were looking at every single sample, it would be going by so quickly that we wouldn't see anything. It wouldn't make any sense.
Yeah.
If we have every 100 samples, now we have something where the audio, it makes a lot of sense.
Yeah, exactly.
Here, check this out. What happens if if I turn this down? Oh no, that's the post, not pre. I don't want to. Yeah. If we turn it down, you can see how quickly it can come in and out. Right?
Yeah.
And if we could slow it down more, if we tried modulo every 200, let's just do it. We'll see it be real slow. 300. So this should be a third the kind of scrolling speed of what we just saw, because we're only getting a sample every 300 samples. Now that also means we're going to miss a lot. We're not going to see samples number 1 through 299.
Yeah, and you're only really going to get one sample per callback with this type of approach.
Yeah. Well, two. Yeah, maybe two, but yeah.
Yeah.
So there you go.
Yeah.
And if we turn it down now, you can see how kind of slowly it's going.
Yeah.
But I don't like that. I like our fast version. So I'm going to go back to every 200. We could also, if we wanted to, have more than 400 points. If we tripled the length, you'd get things scrolling slower, but for a slightly different reason. Okay, it's just so I think that pretty well covers creating the data. I'm sure there's people looking at this that are still there. We go. So this is back at 20 again, and it's pretty responsive, right? And you see when you get those big square ones, that's a low frequency, that's a bass drum being hit. But whatever's happening in the audio, we're capturing enough, we're sampling often enough that we're really seeing what's going on. Which to me, this feels like a good amount of data to be capturing for display purposes. But everybody can change their mind. Yeah, and then if we super overdrive it and it becomes all here, let's get rid of the mids and stuff too. Here's just our lows, all square waved out. And you can really see what's happening. That's the goal here at the end of the day, is to be able to look at the audio and say, I can see what's going on. I can see how I'm affecting it. Cool. So that's building the history array. Should we now talk about, we have that data, what can we do with it to make it look good? How can we make it, fade and all these other fun things?
Great. So now we have the data. We put it into this array called history. So at the moment we're in the process block. So one question that I always get is, okay, well, how do I get that data into the editor?
Yeah, it's super easy. I mean, in this case, we're just accessing the array. So we have history. And down here, we have this function, custom function, that just says get history, and it returns the history. Since it's not a pointer, it's actually going to make a copy of the history at that moment, and return an array of floats to whoever calls get history, right?
Yep.
Which is done right here. So now we're back. This is where we started, 10 minutes ago. Amp oscope, which just happens to be the component that this is drawing in. So not the whole thing, but just that one box. Right?
Yeah. Yep.
So we've got, I think people know this too, but there's children components and everything else. So amp oscope is just this box, essentially.
Yeah.
Right?
Yep.
And amposcope paints probably on a timer. Let me see, start timer 20, right? Oh wait, it's up here. Timer just repaints, yes. Oh, so it moves a few things. We'll talk about those, but then it repaints. So we've got this component. We're telling this component 20 times a second you need to repaint, right? So 20 times a second it goes through and it runs this paint routine.